Bismillahirrahmanirrahim. Hi dear students, hope you are doing well and healthy. Last session we have started the colligative property and we have studied the boiling point elevation. Today's lesson starts from the freezing point depression. What is the freezing point? Is the temperature at which the liquid changes to a solid is called freezing point. And depression, it means in here decreasing. The freezing point depression shows the difference in the freezing point of a solvent and a solution. What is the definition of the freezing point depression? Is the decrease of the freezing point of a solvent on the addition of a non-volatile solute. What does it mean? In here we have solvent and a solution. When we are adding solute into the solvent, it will freeze at a lower temperature than pure water or pure solvent. It is so important that you should understand that solutions every time have lower freezing point than the solvent. It means the solution will freeze at a lower temperature than pure water. In here it's written that any change in the freezing point of a solution is directly proportional to the concentration of molarity and or concentration of molality. We have two formula in here. One of them is belongs to the non-electrolyte solution. Another one is belongs to the electrolyte solution. Delta TF is equal to KF times concentration of molality. Delta TF shows the change in freezing point of the temperature. KF, stereoscopic constant. Also, we have for electrolyte, it has I in here. What is I? One-to factor. As we have studied last session, how we can find the value of I. Stereoscopic constant is varies. It is varies according to the solvent. For example, for water, stereoscopic of water is equal to 1.86 centigrade over mole. Also, it is so important that you should understand change in freezing point temperature is equal to T2 minus T1. T2 shows the solvent, the value, the freezing point of the solvent is 0 centigrade. Also, T1 shows the solution. According to these formulas, we are gonna solve one question. Example, calculate the freezing point of 0.5 m. M is shows in here what? Molal. 0.5 molar sodium chloride solution. Assume that you're at sea level. We should find the freezing point. Also, I categorized our question in here. What is the stereoscopic of water? 1.86 centigrade over molar. Also, it's given as the question concentration of molality 0.5 molar. Also, we have in here I, one-to factor. From where we can find this value? As you know that the ionic compounds split or separate into ions when they dissolve, forming more particles. For example, sodium chloride dissociates into the water. Also, it will give us the sodium ion plus chlorine ion. 1 mole of sodium chloride produce 1 mole of sodium ion and 1 mole of what? Chlorine ion. It means what is the value of I is equal to 1 plus 1 is equal to what? 2. The value of one-to factor is what? 2. According to this formula, because sodium chloride conduct electricity, it is an electrolyte solution, we can find from this formula delta TF is equal to I times KF, stereoscopic of freezing point. Also, we have concentration of molality. Delta TF is equal to, what is the value of I? We have in here 2 times, what is the value of KF? 1.86. What is the value of concentration of molality? 0.5. Delta TF is equal to 2 times 0.5 should be is equal to 1 times 1.86 centigrade. Also, we have in here molar. Also, the unit of stereoscopic was centigrade over molar. We can cancel molar to molar. It remains centigrade. Delta TF is equal to what? 1.86 centigrade. The question asks from us, you should find the freezing point of the solution. Delta T is equal to T2 minus T1. T2 shows the temperature of the solvent. In here it's written solvent, and T1 shows the solution. What is the value of delta TF is 1.86 centigrade is equal to, what is the value of solvent at sea level is 0 centigrade minus T1. When we are simplifying this question, it will give us minus 1.86 centigrade. What does it mean? It means when we have 0.5 molar of sodium chloride into this solution, it will freeze at minus 0.86 centigrade. Let's do another example. The boiling point and the freezing point we have studied. I wanted to solve in here one question about the boiling point. Rank the following solution in water in order of increasing boiling point. It means this question shows us about the dissociation. As I told you, ionic compounds split or dissociate into ions when they dissolve, forming more particles. And like for example sodium chloride or calcium chloride, they are ionic compounds. It means they have ionic bonds to each other. But glucose, as you see in here, covalent compounds stay as complete molecules when they dissolve. Let me do this example. For example, in here we have 0.1 molar sodium chloride. At first you should dissociate sodium chloride into the water. It will give us two particles. One particle, 1 mole of sodium particle, another one is 1 mole of what? Chloride or chlorine ion. It means the value of I is equal to what? 2. Also we can multiply 0.1 times 2 is equal to what? 0.2 mole particle it gives us. Okay, next one. As I told you, glucose has covalent compound. It is a covalent compound. Also glucose stay as complete molecule when it is dissolved into the water. For example, 0.1 mole of glucose, it will give us 0.1 again. These are our result. Also we have in here 0.1 molar of what? Glucose, calcium chloride. How many particles does it have? Dissociate into 3 particles. One of them is calcium ion plus 2 mole of chlorine ion we have in here. How many particles do we have? 1 plus 2 is equal to what? 3 particles. It means we are gonna simplify that. 0.1 times 3 is equal to 0.3 mole particles we have in here. As you know, if we have more particles, the boiling point elevates or increase the boiling point. In here, we are gonna rank the solution according to increasing boiling point, because calcium chloride has 0.3 mole particles. It means it has 0 calcium chloride. Another one is 0.2. We have in here 0.2. Sodium chloride in HCl 0.2. Another one is glucose. Hope you learned something from this lesson. Also, that's all for today. Thanks for your watching me.